Sharing a neutral wire on a 3-wire home run protected by 2 separate arc fault circuit breakers for 2-bedroom circuits is not permitted. Nuisance tripping can occur when 2 arc fault circuit breakers protect the same neutral wire. If one circuit experiences an arc fault, both arc fault circuit breakers may trip, unnecessarily interrupting power to both bedroom circuits. The National Electrical Code requires each branch circuit to have its own dedicated neutral conductor. Sharing a neutral conductor between 2 arc fault circuit breakers violates this requirement. To comply with the NEC and prevent nuisance tripping, separate neutral conductors should be run for each bedroom circuit. Each arc fault circuit breaker should protect its own neutral wire. In a standard electrical system, the neutral wire serves as the return path for current from electrical devices back to the source, typically the service panel. Arc fault circuit breakers are designed to detect dangerous arcing conditions which can lead to electrical fires. They do this by monitoring the current waveform for unusual patterns that indicate an arc. When an arc is detected, the arc fault circuit breaker trips, cutting off power to the circuit. Sharing a neutral wire between 2 circuits introduces the possibility of current from one circuit flowing through the neutral wire of the other circuit. This can create imbalances in the current flow that can trigger the arc fault circuit breakers, even if there is no actual arc fault present. Furthermore, the National Electrical Code, or NEC, specifically prohibits sharing a neutral conductor between 2 branch circuits protected by arc fault circuit breakers. This is to ensure that each circuit has a dedicated return path and to prevent the problems associated with shared neutrals. To properly wire 2 bedroom circuits with arc fault protection, each circuit should have its own dedicated hot wire, neutral wire, and ground wire. The hot wire carries the current from the service panel to the electrical devices in the circuit. The neutral wire provides the return path for the current back to the service panel. The ground wire provides a safe path for current to flow in the event of a fault, such as a short circuit. Each circuit should also be protected by its own arc fault circuit breaker in the service panel. The arc fault circuit breaker should be properly sized for the load on each circuit. This means that the breaker should be rated to handle the maximum amount of current that the circuit is expected to draw. For example, a typical bedroom circuit might be wired with 14-gauge wire and protected by a 15-amp arc fault circuit breaker. Alternatively, it could be wired with 12-gauge wire and protected by a 20-amp arc fault circuit breaker. The size of the wire and the breaker will depend on the expected load on the circuit. When installing electrical wiring, it is important to follow all applicable electrical codes and safety regulations. This includes using the proper wiring methods, making secure connections, and properly grounding all electrical equipment. If there is any doubt about how to properly wire an electrical circuit, it is best to consult with a qualified electrician. To further elaborate, let's consider the specific requirements of the National Electrical Code, or NEC, regarding neutral conductors and arc fault circuit breakers. The NEC is a widely adopted standard for safe electrical installations. It is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. The NEC contains detailed requirements for wiring methods, overcurrent protection, grounding, and other aspects of electrical installations. Article 210.4 of the NEC addresses multi-wire branch circuits, which are circuits that share a common neutral conductor. While multi-wire branch circuits can be a cost-effective way to wire a building, they also require careful planning and execution to ensure safety. The NEC permits multi-wire branch circuits under certain conditions, but it also places restrictions on their use. One key restriction is that multi-wire branch circuits serving dwelling units must be protected by a multi-pole circuit breaker that simultaneously disconnects all ungrounded conductors. This is to prevent the neutral conductor from becoming overloaded in the event of a fault. In addition to the general requirements for multi-wire branch circuits, the NEC also has specific requirements for arc fault circuit breakers. Section 210.12 of the NEC requires arc fault circuit breaker protection for all branch circuits serving dwelling unit bedrooms, living rooms, dining rooms, family rooms, recreation rooms, and similar areas. This requirement is intended to reduce the risk of electrical fires caused by arc faults. As previously mentioned, sharing a neutral conductor between two arc fault circuit breakers can cause nuisance tripping. This is because the arc fault circuit breakers may misinterpret the current flow in the shared neutral conductor as an arc fault. To avoid nuisance tripping, the NEC requires that each branch circuit protected by an arc fault circuit breaker have its own dedicated neutral conductor. This means that the neutral conductor must originate at the service panel and run directly to the outlets and devices served by the circuit without being shared with any other circuits. In addition to preventing nuisance tripping, using separate neutral conductors for each arc fault circuit breaker also improves the overall safety and reliability of the electrical system. It reduces the risk of neutral conductor overload and ensures that each circuit has a dedicated return path for current. When wiring a home or other building, it is important to carefully consider the requirements of the NEC and to follow all applicable electrical codes and safety regulations. This includes using the proper wiring methods, making secure connections, properly grounding all electrical equipment, and providing arc fault circuit breaker protection where required. If there is any doubt about how to properly wire an electrical circuit, it is best to consult with a qualified electrician. They can provide expert guidance and ensure that the electrical installation is safe and code compliant. To further clarify the concept of nuisance tripping, let's consider a scenario where two bedroom circuits share a neutral conductor and are protected by separate arc fault circuit breakers. Suppose that one of the circuits experiences a minor arc fault, such as a loose connection in an outlet. The arc fault circuit breaker protecting that circuit will detect the arc and trip, cutting off power to the circuit. However, because the two circuits share a neutral conductor, the arc fault current may also flow through the neutral conductor of the other circuit. This can cause the arc fault circuit breaker protecting the other circuit to also trip, even though there is no actual arc fault on that circuit. This is known as nuisance tripping because the second arc fault circuit breaker is tripping unnecessarily. Nuisance tripping can be a frustrating problem for homeowners, as it can cause unexpected power outages and disrupt the use of electrical devices. It can also be difficult to diagnose, as the cause of the tripping may not be immediately obvious. In the scenario described above, the homeowner may initially suspect that there is a problem with the second circuit, when in fact the problem is with the shared neutral conductor. To prevent nuisance tripping, it is essential to avoid sharing neutral conductors between circuits protected by arc fault circuit breakers. Each circuit should have its own dedicated neutral conductor that originates at the service panel and runs directly to the outlets and devices served by the circuit. This will ensure that the arc fault current from one circuit does not flow through the neutral conductor of another circuit, preventing nuisance tripping. In addition to preventing nuisance tripping, using separate neutral conductors for each arc fault circuit breaker also improves the overall performance of the arc fault circuit breakers. It allows them to more accurately detect arc faults and to trip only when necessary. This can help to reduce the risk of electrical fires and to improve the safety of the electrical system. When wiring a home or other building, it is important to carefully consider the requirements of the NEC and to follow all applicable electrical codes and safety regulations. This includes using the proper wiring methods, making secure connections, properly grounding all electrical equipment, and providing arc fault circuit breaker protection where required. If there is any doubt about how to properly wire an electrical circuit, it is best to consult with a qualified electrician. They can provide expert guidance and ensure that the electrical installation is safe and code compliant. Now, let's delve into the practical implications of the NEC requirements and how they affect the installation of electrical circuits in residential buildings. The NEC, as mentioned earlier, is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated regularly to reflect the latest technological advancements and safety practices. Compliance with the NEC is essential to ensure the safety of occupants and to prevent electrical hazards. When wiring a residential building, electricians must adhere to the NEC guidelines regarding the sizing of conductors, the installation of overcurrent protection devices, the grounding of electrical systems, and the use of arc fault circuit breakers. These requirements are designed to minimize the risk of electrical fires, shocks, and other hazards. One of the key aspects of electrical safety is proper grounding. Grounding provides a low-resistance path for fault current to flow back to the source, allowing the overcurrent protection device to trip and to energize the circuit. This prevents dangerous voltage from building up on metal enclosures and equipment, which could pose a shock hazard. The NEC specifies detailed requirements for grounding electrical systems, including the use of grounding electrodes, grounding conductors, and bonding jumpers. These requirements must be carefully followed to ensure that the electrical system is properly grounded and that the risk of electrical shock is minimized. Another important aspect of electrical safety is the use of overcurrent protection devices. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow. When the current in a circuit exceeds the rating of the overcurrent protection device, the device will trip, cutting off power to the circuit. This prevents overheating of conductors and equipment, which could lead to electrical fires. The NEC specifies detailed requirements for the sizing and installation of overcurrent protection devices, including the use of appropriate ampacity ratings and the coordination of overcurrent protection devices. These requirements must be carefully followed to ensure that the electrical circuits are properly protected from overcurrent conditions. In addition to grounding and overcurrent protection, the NEC also requires the use of arc fault circuit breakers in certain areas of residential buildings. Arc fault circuit breakers are designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. Arc faults can occur when there is a break in the insulation of a wire, causing current to flow through the air. This can generate heat and sparks, which can ignite nearby combustible materials. Arc fault circuit breakers are able to detect arc faults by monitoring the current waveform for unusual patterns. When an arc fault is detected, the arc fault circuit breaker will trip, cutting off power to the circuit. This prevents the arc fault from escalating into a fire. The NEC requires arc fault circuit breaker protection in all branch circuits serving dwelling unit bedrooms, living rooms, dining rooms, family rooms, recreation rooms, and similar areas. This requirement is intended to reduce the risk of electrical fires in these areas. When wiring a residential building, electricians must carefully consider the requirements of the NEC and follow all applicable electrical codes and safety regulations. This includes using the proper wiring methods, making secure connections, properly grounding all electrical equipment, and providing arc fault circuit breaker protection where required. If there is any doubt about how to properly wire an electrical circuit, it is best to consult with a qualified electrician. They can provide expert guidance and ensure that the electrical installation is safe and code compliant. Furthermore, it's essential to understand the difference between a shared neutral and a multi-wire branch circuit. While both involve a single neutral conductor serving multiple circuits, they are distinct concepts with different requirements under the NEC. A shared neutral, as discussed earlier, refers to a situation where a single neutral conductor is used for two or more separate branch circuits, each with its own ungrounded hot conductor and overcurrent protection. This configuration is generally prohibited by the NEC, especially when arc fault circuit breakers are involved, due to the risk of nuisance tripping and potential for overloaded neutral conductors. A multi-wire branch circuit, on the other hand, is a specific type of circuit configuration permitted by the NEC under certain conditions. It consists of two or more ungrounded conductors that have a voltage between them and a neutral conductor that is common to all of the ungrounded conductors. The ungrounded conductors originate from different phases of a multi-phase system, such as a 240/120 volts or a 208/120 volts system. Multi-wire branch circuits are typically used to supply both 120 volts and 240 volts loads in a residential building. For example, a multi-wire branch circuit could be used to supply a 240 volts electric range and a 120 volts lighting circuit. The NEC allows multi-wire branch circuits under specific conditions, including the requirement that all ungrounded conductors be opened simultaneously by the branch circuit overcurrent device. This is typically achieved by using a 2-pole or 3-pole circuit breaker that disconnects all of the ungrounded conductors at the same time. The NEC also requires that the neutral conductor of a multi-wire branch circuit be sized to carry the maximum unbalanced load. This means that the neutral conductor must be large enough to handle the current that would flow if all of the ungrounded conductors were carrying their maximum rated current. When installing a multi-wire branch circuit, it is important to follow all of the NEC requirements carefully to ensure that the circuit is safe and code compliant. This includes using the proper wiring methods, making secure connections, properly grounding all electrical equipment, and providing overcurrent protection that meets the NEC requirements. In addition to the requirements for multi-wire branch circuits, the NEC also has specific requirements for the installation of electrical receptacles. The electrical receptacles, also known as outlets, are the points where electrical devices are connected to the electrical system. The NEC specifies the types of receptacles that are permitted in different locations, the spacing requirements for receptacles, and the grounding requirements for receptacles. One of the key requirements for receptacles is that they must be properly grounded. Grounding receptacles provides a low resistance path for fault current to flow back to the source, preventing dangerous voltage from building up on the metal parts of the receptacle. The NEC specifies several methods for grounding receptacles, including the use of grounding conductors and self-grounding receptacles. When installing receptacles, it is important to follow all of the NEC requirements carefully to ensure that the receptacles are safe and code compliant. This includes using the proper wiring method, making secure connections, and properly grounding all receptacles. In summary, the NEC provides a comprehensive set of standards for the safe installation of electrical wiring and equipment. Compliance with the NEC is essential to ensure the safety of occupants and to prevent electrical hazards. When wiring a residential building, electricians must adhere to the NEC guidelines regarding the sizing of conductors, the installation of overcurrent protection devices, the grounding of electrical systems, the use of arc fault circuit breakers, and the installation of electrical receptacles. These requirements are designed to minimize the risk of electrical fires, shocks, and other hazards. It is always recommended to consult with a qualified electrician for any electrical work to ensure safety and compliance with the NEC.